Alright, let's start with this one. So this population is increasing 1.8%. What's the quarterly rate? So what do you do? Go ahead. 1.018.
Oh no, what is this?
Okay. So you can put the plus. I'm just doing the next step.
Oh.
Okay, and then what? Yep. Or again, well, I guess I don't want to keep saying this too many times, but just take a poll. How many of you are doing the rational exponent? How many of you are doing the radical? Okay. Well, either one. What'd you get?
0.44%.
Okay, so we get 1.0045. I'm going to write it that way. What is this called? Like as an intermediate step, what's that number I just wrote called? Quarterly growth factor, right? Okay, so let me put this in context. If I said, in terms of this town, if I said, what's the population after 4 months? Or after 5 months or something? Not months. Darn. Well, quarters are kind of weird, but 3 quarters, which is how many months? 9 months. If I said after 3 quarters, this is what you would plug into your function now, right? And you would take it to the third power. Does everybody understand that? Yeah. Okay. But as a rate, which is what this is asking for, we subtract 1 and then convert it to a percent. So which is what? 0.45%. Yeah. Any questions on that one? How'd that go? 100% across the board? Cool. Alright, next. I'm just going to call on random people to give the number. You see the setup here. So I want you to not just focus on the answers, though. I want you to think about what did you expect to happen as we increased the compoundings? Because obviously everything else, if you didn't write this out on your paper, everything else is the same except for the denominator and that one of the factors of the exponent, right? Went doubled to 2 and then to 4 and then 3 times to 12. So what did you expect to happen when you were plugging that in? Did anybody think before you did that? So increasing the compoundings should what?
Overall increase.
It should increase the money, right? Because think about it. We're basically what we're doing here. Everybody look, because I'm pointing to stuff. For annually, we're only dumping that interest back into the account once a year. Here, we're doing it twice, and then down at this point, we're doing it 12 times. So that interest is gaining interest more frequently. However, it's a lower rate, right? So they're kind of battling each other. Like here, we chop the rate into 12 pieces, but we're compounding it 12 times. Whereas here, we take the full rate, but only compound once. And so one seems to be increasing the value of the account, while the other seems to be decreasing. But they kind of end up increasing the account. Did you see that happen as you plugged in the numbers? Yeah. So let's go ahead and give me a value. We'll just kind of go around. So Braden, what'd you get for this first one?
First one I got 5,600.
24. Okay, and this is money, so we'll keep it at 2 decimal places. Okay, so that was just one compounding. Notice we ended up with $624 in interest, which is over 3 years, which is kind of a lot, right? I mean, just free money-wise. Okay, and then Jorge, what'd you get for semi-annually?
Somebody got 5,630.12.
Okay, so that was an extra $6. Same time frame in the bank, just compounding twice as often. And we got an extra $6 out of it. Okay? Tom, what'd you get for quarterly?
5,634.12.
Yeah, I actually it's 0.8 for them.
Point.
Gee, Jorge.
My bad.
We forgot the 80 cents.
Alright, but do I have the next one right? The 34? Okay. Alright, so a little bit more money, but notice this time it went up 6, but now it only went up 4. Roughly 4. Okay, and then how about, Andre, what'd you get for the last one?
5,636.36.
8.6?
36.
3.6? Okay, so now it's only going up $2. So the amount that it's going up each time is decreasing, but it's still going up, right? So what would you predict if we did weekly and daily? What would you predict to happen?
Only go by like $1 or a couple cents.
Okay.
Half a dollar.
Do you think we'll ever get to 5,640?
If we do it every.
Okay. Why don't you go ahead and plug in daily and see if it happens to get there. How many days are in a year? But what if it's leap year?
366.
Oh, it's because I was just talking instead of.
365 and a quarter.
There you go. It's actually 365 and a quarter.
Because there's a fourth of a day every year. So every 4 years we get an extra.
Is it 4?
He's not talking about the money. He's talking about
What?
Every year it's
That is not,
365
it's not
days
40,
and
it's
a
like,
fourth of
it's
it.
$1.
Okay, what is it?
But you can't just have a fourth of a day.
44. So where does that time go? 45.
Every 4 years, when there's been 4 fourths of a year,
Oh.
we
How did I take a random facts class?
That's random
It's like
fact.
365 days in a
Every 4 years you get an extra day in February.
Where do you think that?
It's like one of the worst months.
No, I actually.
We need an
Oh, we
extra
have
day
an
in
extra
June
day
or
every
July.
4 years for that.
And it was just like another.
Just for the rain.
Yeah. Alright, so notice this time, like 12 to 365 is 30 times more compounding, and yet it only went up $1. So it's still going up, but the amount it's going up is decreasing. So here's what I want you to do. I want you to graph
Oh.
what the function, like if we graph these values, our x-axis is going to be compoundings. So as those go up, what happens to the money? Okay? Just sketch a little graph to illustrate what's going on.
Exponential.
Can you scroll up? So I can see all the down.
I mean,
So I think. Oh my gosh.
you're welcome.
Thank you. Did you do it to me? No. I'm full. Well.
Did you cheat and use your calculator?
Just for the initial number, because I got that first one wrong, so I was looking for it.
I haven't seen a correct one yet.
Right here you did.
Right.
Right here.
Right there, I did not.
It's literally.
Guys, you don't need to do numbers. I just want you to sketch the shape of the graph.
Oh.
Oh, that's mean.
Sorry if that was. One that's pretty close.
Oh wait, cause
No.
Miss Radcliffe, I got it. I got it then.
No.
Would it be something like that? Wait,
There we go. I got it. I got it.
No.
5.
Because it levels off.
No.
Yeah, sort of. Yeah.
Yes, it can.
Picture.
Because it goes up by 20 cents if you go from the daily to the weekly.
Oh.
No, it should go down if you go daily to weekly.
Or weekly to daily.
Okay.
One of
What
them. 20 cents, so it's 11.
This one was right.
What?
Got it.
Oh my. You know what?
No.
Think about it. She just had a rough day. She had a schedule this morning. Yeah.
Oh my gosh.
No.
Wait, the schedule start
Depending
as
on
early
your
as already.
attendance.
Yeah.
If you have good attendance.
Ew, I literally missed like 2 days. How am I so late in Wednesday?
Alright, let's check.
What time is it?
Okay, this is what's happening. It's not one of the graphs that, like one of exponential or decay or anything like that. So it's initially it's changing quite a bit, and then it starts to change less, right? Eventually, it's still going to keep going up, but it's not going to go up very much after a while, okay? And like we saw, like from here to here was once to twice, so that was the biggest jump. Out here it was, what did you say, 22 cents?
Pretty much.
So Audrey did weekly in between here, and it changed very little between weekly and daily, okay?
Is it the y equals the square root of x? Is that
It is very similar to that, yeah. He's noticing that it kind of fits that shape. It's not exactly, but yeah, it's a similar graph to that. Nice. That's very cool. Good job. Alright, so here's my question. What if we keep pushing this to always, continuously, those kind of words?
1 cent.
Compounding. So it's, like you said, 1 second, but we could even break down 1 second into partial seconds, right?
Even then, you won't be getting anything for a certain amount of time, and then you'll finally get a cent. And then for a certain amount of
We're just constantly doing it. What do you think will happen?
It will infinitely go up, but it'll take forever.
Do you think it's going to jump,
It'll never jump.
or do you think it's going to just continue?
It's just gonna continue.
Almost extremely
Okay, so what we're going to do is leave this graph and come back to it. We're going to change our parameters, these numbers, just to make this a little bit more obvious. And here, actually, I'm just going to write it at the bottom of this. So this time I'm going to split up everybody up so we can do this a little bit faster. Here's the plan. We're going to invest invest $1. Does this bug you guys if I put the dollar sign on the right side?
Yes.
Yeah. That's
I never
wait.
paid attention to dollars.
I figured it would.
I will freak
I thought when you're writing.
So I'm just going to leave it.
Bruh. I thought
When it doesn't even add up.
I never paid attention to dollars.
Okay, we're investing $1 for 1 year at 100% interest. Okay? Which means after 1 year, what do you have? It doubles, right? We learned that yesterday. Okay, but here's what we're gonna do in terms of like splitting everybody up. First of all, what's our function rule for this? So B for this scenario that I've written so far. One. Well, I haven't said that yet.
Oh, and
Oopsie.
And
times 1.
Okay. Okay. So what we're planning to do, like the one right above this for the $5,000, we got up to 365 compoundings in a year. Okay, compared to continuous, that's tiny, right? So we're gonna go through and do 1,000, like the right side. Well, to me it's the left side, but you guys know what I mean. So Ryan, I'm just gonna say it. Ryan, Nate, and Jazzy, you guys are doing 1,000, and you're gonna tell me a value, okay? Okay, and then Braden and Lexi, I want you to do 100,000. This middle row, do 1,000,000. Last row, I want you to do 100 million.
That's a lot.
How many zeros?
Actually, hold on. Cooper, Audrey, and Tom do 100 million. And Gabe, tell us, you're going to figure out how many seconds are in a year.
Okay.
Okay.
I should know this off the top.
Just so we kind of know where that falls in this. You probably shouldn't know that off the top of your head. It'd be cool. First group, what'd you get?
2.71692 yada yada yada.
Alright, 2.716
Yep.
of 69. Alright, everybody's gonna do 5 decimal digits. So 7169 what?
2.
Thanks. 2. Alright, 10,000 group.
Oh, were we? No, I did 100,000. Yeah, you have 5 zeros.
Yeah, you have 5 zeros.
100,000, sorry.
2.71826.
Good.
Yep.
And it does keep going.
Yeah.
Okay, middle group. 1,000,000.
2.718280.
100,000,000.
2.718281.
Okay. So I'll leave on those last two, I'll leave the 6 decimal digit. And then Gabe figured out seconds per year falls in here in about 31 what?
31,536,000.
Okay, so about 31.5 million seconds. So by the time we get to 100 million, it's more than, it's about 3 times per second, right? So continuous means constantly, but that's still, like, conceptually 3 times a second is a lot, right? Everybody clear on what we just did?
Yeah.
Okay, what do you notice?
You won't climb a bit, like 1 cent for a while.
Yeah, I mean, the difference between 1,000 and 100 million compoundings doesn't take effect until out here in the thousandths place. So it's not changing it much, right? So did our graph jump at all?
Not at all.
Not at all. Okay, but here's what's cool. Setting it up this way with $1 at 100% for 1 year, that number is what we call the natural base, and that's the number E. Okay, 2.718. In fact, on your calculator, everybody go to the E button. It's over here, left of the number 4. And if you just hit E to the 1 and hit enter, there's 2.718 and some more digits. Yours will be with the natural log button.
2.71.
Okay. I don't hold it up here. I don't have it. Oh, it's just to the left of it. E to the X. Okay, so I know this seems maybe insignificant, but we just discovered, or we just developed a number that's like pi. So pi, we know, is a constant that relates what two quantities? Not radius. So circumference. I'll just write it because you'll visualize it better. So circumference divided by diameter is the constant for any circle, right? Big, small, microscopic, enormous. Pi is a constant in nature, in the world. We just figured out another one, which is E. We call it E. But what it is this natural quantity, this natural constant. This is one way to arrive at it, but it takes place in a lot of things in nature. And you'll see that as we do some more math, okay? So let's go write this result, and kind of like pi, we're not going to try to memorize a whole bunch of the digits because they go on forever. So 2.718 is typically good enough, okay? 2.718, but also you have your button on your calculator. Those of you going into engineering, and sciences, you'll come across E a lot.
Oh, come on, I don't want to do it.
Or what we use in the inverse of E is what we call the natural log. And that will come up even more, actually. Alright, so this is still under compounding, but now it's continuous compounding. You will not have to guess or figure out if something is compounding continuously. You will need to be told that. Okay? So you'll either need to read compounding monthly, quarterly, weekly, etc., or it will say continuously compounding. In that case, you're going to use this formula. P is still the same, but now our compound interest formula changes to this. E, that's that natural base, we'll write about it in a second. E to the RT. RT are both the same as what was before.
I don't like the way this looks.
Hurt, yeah. It is, hopefully you agree, it's a much simpler equation, right? We don't have the 1 over, and we only have, well, E, it looks like a value you plug in for, but it's just a constant. It's always the same number, 2.718. So you don't have to worry about what your base is now. Are you hearing me?
Yeah.
Are you listening to what I'm saying?
Yeah. Yeah. I don't have to worry about what E is because it's always 2.118.
2.718. See, you weren't listening.
Oh. Good point, son.
All right.
Good thing there's a button on my calculator.
Good thing. So just remind yourself
Yeah, there's 2 buttons actually.
that PR and T are the same as before, but E is different. So let's write about it separately. That does not look like E. So at this point, you should be able to tell me 3 mathematical constants that are given by letters. Can you?
Oh, no.
Don't say him, but he can. Who else?
Wait, what?
3. You should be able to tell me 3 mathematical constants that are given by letters that we know at this point.
3.1415.
You're saying it. Hold on. Nobody else?
Can we learn it in geometry?
No, we learned it in algebra since Christmas.
Oh, well.
Wait, what?
It's not in this one.
I learned one.
Okay, Ryan, tell us.
Pi I E.
Oh, yeah.
Oh.
But that's not.
I doesn't really count though.
I is
Yeah,
the
what?
first.
I represent something.
Isn't that? It spells pi. P-I-E. Pi.
I love it.
Wow.
I
Just
love
now
it.
notice that?
You're.
I
Did
love-
you?
I love the E.
You're so
Well,
funny.
I never knew that.
You didn't even know how to list them. Physics, there's a bunch more, but
Yeah, like planks.
yep.
Great
The
first
Bohr
constant.
magneton.
That sounds boring. After.
Alright,
It actually
E.
smells
We call this the natural base. Its value is approximately 2.718. It is a constant. I'm going to write that in a different color. What is the problem?
Thank you.
It's a constant. Okay. Anyway, so now you can deal with problems that say, hey, it's compounding continuously. Did you guys notice that on your problems last night?
No.
Okay.
I did not look at any of the other ones besides the one I had to be.
Yeah. Now you can do those. It's actually easier to do it that way, surprisingly. But it doesn't change too much from what we saw before. So our graph, even if we go out too continuously, it doesn't change this trajectory at all. It's just the same. Okay? So you won't probably ever be offered continuous compounding in a bank situation, but that would be cool.
Is there any way we could change the equation to make it like shoot up again?
Again. It never did really shoot up.
Well, like, from the beginning we shot up a bunch and then we flattened out.
Well, I mean, we shot up like $6. Is that?
Oh yeah.
That was on $5,000.
Yeah.
Anyway, I guess to answer your question,
You'd have to put
think about, let's kind of think about the shape of that. What are you starting to call that shape?
It's like a cube.
Cubic. Good job, guys. Way to go. So, yeah, if we maybe stuck a cube on there or something, it would come back up. Let's check your homework, and then we'll see how that goes. Number 12.
Kill it?
Yeah, I think so.
Okay, number 12. Student compounded the interest monthly instead of quarterly. Oops. So what they put in instead of what they should have. Good. So this says $7,935.16. Any questions on that one?
No, that was pretty.
Next one. 16 through 19. 16, you should have got $1,367.31. 17, $7,543.88. 18, $4,469.79. 19, $1,716.79.
Can you do
19 went great. I don't know what.
Yeah, I can do 18. Let's finish checking and then we'll do those.
Okay.
25. Multiply the, oh, that's how you set it up. I'll have to do that one too because we changed that question a little bit. And then 28. 28. Is this the same question? By what percent? Okay, so daily percent should be 0.0149%. Daily rate. 0.0149. Good? Okay, so we need to do 18 and 25. Let's see if I have.
Yeah, no, I saw some creepy crawly on the floor walking to this one.
Where?
It was while walking to this one.
Yeah,
It's
no,
right
there's
there.
cockroach right there.
Is there another
It
one?
like ran at me full speed for some
Alright, so 18, $2,400 at 5.25% over 12 years, semi-annually. So this is 2,400 times 1 plus 0.0525 over 2 to the 2 times 12.
Yep.
Does that help with?
Yep, I
Okay.
put a 6 on one.
Alright, 25 isn't on here, so let me just write it.
Oh, I know what I did.
25 should be this, 1.017 to the 1/4 for quarterly.
No, there's a lot.
So 4.42%.
Oh, you're dead it now.
Yeah, that one didn't have it, so.
You didn't have
Okay, any others we need to do?
No. I understand what I did.
Okay. Why don't you do 20 and 21? you'll find that it's a lot easier. Well, somewhat easier than the other. Actually, let's change that. Do 21 and 29. 21 and 29, please.
Sorry, I accidentally started 29.
It's either that one or it's one down in Texas. That I can go
All right, so for 21, you should be doing 16,000. E, remember there's no 1 plus in here. It's just E to the 0.04 times 25. So no worrying about putting ones or anything. Also, you can just do E to the X, the button, the blue button above the natural log button by the 4. Okay? And then 0.04 times 25 just goes up there in the exponent. And we get 43,492.51. Right?
You did that wrong too.
No, I literally got the right answer though. It's not 42,000. I literally did it right. 492.
How'd that go?
Great.
Did you find it easier than putting the 1 plus in there?
Yeah,
Yep.
that's just
Pretty much the same.
Even though I did it wrong.
Why is it interesting?
1 plus. It just takes a lot more time.
What does?
The 1 plus thing. It's out.
She's saying she likes this better because the other one takes more time. She's lazy, doesn't like doing that.
Heck, man. Not sure I like the attitude today.
They just treat you like that one.
All right, 29.
Okay, and then I'll just start rising.
I did 29.
I gotta get my
Go back here. Yes.
Yeah, I can just do that right now.
Yeah.
All right, so this question is asked a little differently. Let's see how you did on it. When you plug this in,
Today.
also do be careful with this percent as a rate or rate as a decimal. Make sure you get all the 225.0225. And then the time again was given with years, not the actual number of years, but the dates kind of. So this is our new total, 490504.
What did I do wrong?
At 46.
Okay, but that's not what the question asked. And so if you put this as your answer on a test question, I wouldn't give you credit because what did it actually ask for? The amount of interest you earned. Okay, so the interest is how much you gained over your initial principal, which means we have to subtract the 3,500 initial investment. Okay? So make sure you're reading carefully. So you got $1,405 interest.
That's good interest.
And 4 cents. No.
Yeah, and 4 cents.
Yeah.
Okay.
That's enough to pay taxes on half.
All right, next question. Yeah, on right. Hold on. Yes,
I did not get
sorry.
Oh!
wow. Okay. Finally.
Well, what was your equation?
3,500 E 0.0252 times 15.
It should be 225.
Oh, that's.
Okay. All right, so here's the next question. Let's say you earn $5,000 this summer, and for some reason it's getting compounded continuously at 4%, and you want to know how long you need to leave that money in the bank to end up having $7,500. In other words, when can you come back and get the money? Maybe you want to use that for a car or something. How long would you have to leave it in there? How do you solve that? You do. You want to get t by itself. So what's a good first step?
Divide by 5.
Yeah.
Yeah.
No, it's easy. Just give T with.
Then square
No,
root y
Plot
0.
something.
How do I get t out of the exponent?
Square root by T.
Y 0.0.
Well, it's undoing an exponent, right? So division undoes multiplication. Square rooting undoes squaring. Is that what's going on here?
I mean, they're not square root, but like root of 0.0.
Okay. But it's not 0.04 only, it's 0.04 t.
So you have to divide by
But that undoes
the
multiplication.
square root.
Square rooting undoes squaring.
Well, so like you're multiplying 0.04 by t. So to get that undone, you have to divide
And root it. Same
by
column.
t or by.
Okay, so everybody's trying to go to multiply and divide, but this isn't that, right? This is exponential. So, any other thoughts?
Burned out.
You've burned it all up, huh? Okay, but do you see the issue? Up to this point, you probably have never solved for a variable in the exponent without just guess and check. Like you could just start plugging in values to see where t would give you 1.5. But that's kind of dumb. Like who wants to do that all the time, right? Like it's slow and inefficient. So the second half of our unit, well, a little more than, is addressing how do you deal with that? Like we need an algebraic way to get t out of the exponent or x out of the exponent and be able to solve for it. Ryan, tell us what you said.
You have to use log.
Okay, so in order to undo an exponential, we have to use this new function called a logarithm. That's the inverse. So just like square root undoes x squared, log, and in this case we have to be a little more specific because we need to talk about what base it is. But like log base 2 of x, of 2 to the x is x. So it undoes. So here's an exponential, 2 to the x. Here's a log base 2. Those cancel and leave us with x. Okay? Just like over here, if I said, how do you get rid of x to the 7th? What has to go here? The 7th root. Well, same thing. If I wanted to undo 7 to the x, what would I have to take? Log base 7 to get x back. Okay?
So you gotta take out log e.
So what's our base here? E. So we would need to do log base e of both sides. And then that cancels that e to the power of. And we're just left with 0.04 t on the right side, because that cancels that. They undo each other, they're inverse operations. And then log base e is actually written as ln. If you look on your calculator, what's the main button for e to the x? ln, that stands for natural log. Natural base, natural log. Okay? Anyway, so log base e, natural log of 1.5, that's just a number. In fact, you could tell me what that means. Roughly what power of e gives 1.5? Just ballpark it. What power of e would give 1.5? Yeah, like maybe a half power, or maybe 3/4 or so, right? And then we would just divide off the 0.04. Okay? So go ahead and on your calculator do the natural log of 1.5 and see if you're right. Okay, you said half, this is 0.4, so yeah, you did a good job. So this is 0.4. How many times does 0.04 go into 0.4? 10 times. Okay, so this would take 10 years of leaving your money in there to earn that $2,500.
Yo, I literally said it at the beginning.
Did you?
Yeah, that was my guess.
Okay. So that is, we're going to do a lot more with logs. Like we have to learn log properties. How do you solve these different versions of equations? Either is it a log equation that we need to use exponentials for, or is it an exponential that we use logs for? And also we'll talk about the log graph. I'm not super big into that too much, so we're not going to do a lot with it. But that's kind of a preview of where we're headed. We're going to stop here for now, and we're going to do some SAT review. So why don't you grab your Chromebook, please? 3 minutes to find x plus y. All right, so you just finished your roughly how much time you budgeted for this one. What do you do if you aren't done?
Pick your letter.
Keep going.
There isn't one.
Click
No.
the bookmark button.
Okay. You've done some work, hopefully, right? Hopefully you didn't just stare at it. Because that, if you did just stare at it, that's a total waste of time, right? So we're going to talk strategy as well as math, but guys, you have to just accept the fact that doing well on an SAT is a lot of strategy, not just math, right? Okay? So, absolutely don't just stare at a problem. If you're not working, like maybe look at it for 10, 20 seconds and then either decide to work or decide to move on. But don't just stare because that's a waste of time. Okay? Second, if you've done some work and you have some idea, don't leave it blank. Like never leave a problem blank because that counts against you, whereas wrong answers don't. Everybody clear on that?
Wait, really?
Yeah, wrong answer. There are tests that you might take in life that wrong answers actually subtract points, whereas here a wrong answer is just you just didn't get it. It's not a penalty. Does that make sense?
But like if you don't answer.
But it. Well, no. If you don't answer, it's still no points. But then you didn't give yourself a chance to have it correct. So a blind guess is better because what if you happen to guess the right one? Okay? So no blanks, none at all. So you finished. Maybe you just throw out a guess based on your work, but let's talk about what you should have done. First of all, these are parallel lines. So remember the notation was arrows on the line. In case they happen to put that instead of actually saying the word parallel. So we can copy this 123 in various places, like where? Could go there. What? That's a corresponding angle.
I can also reflection.
Yeah, here. That's a what? That's a vertical angle. Good. Remember the congruent arc mark? Okay, where else can 116 go?
Yeah.
Okay.
And on the
There, 116. Also, 116 to this 116 is called what? Alternate. Good. Yep. All right, 81 of course can go here. How can we find that angle?
By subtracting 81 from 180.
Yep. 99. So it's good. It's a linear pair. So you could start by putting all this in here, right? And figuring out, at least is maybe having more information will help you see what you can do. But we still don't have a way to set this up yet. Do you see that? So what would you do next? How big is that whole angle?
57.
57.
So it's the linear pair angle with 123. So the whole thing is 57. So how big is just this angle? Yeah. I'm getting too many lines here. Let me reverse those. Okay, how about that one? And now you're looking here at that triangle. And we have 3 angles, or at least 3 expressions in one triangle now. So what can those be added up to?
180.
Okay, so we get 81 plus 57 minus x plus 64 minus y equals 180, because they're in that triangle together. Okay, then we clean up terms. So 81 and 57 and 64 is what? So 81 and 64 is 145, 195, so 202.
I see.
Okay, now what? Okay, and this is what's frustrating about SAT. They didn't ask you what x and y were, did they? And in fact, you can't solve for them. But they asked you for the sum of x and y.
Which is 22.
Yeah, if we just divide out a -1 or multiply by -1, then we get x plus y equals 22, which is what they asked for.
Oh,
That's actually current.
That's
Nah,
evil.
I don't like that.
That's garbage, right? Because what are we used to doing when we see that? Solve for both. So just know that there's, I think this is kind of tricky, right? And just know that sometimes to answer correctly, you're looking for the back door instead of just knowing the math. Because we know the math, we know how to set stuff up, and then we want to solve for x and y, but that's not what they want. And they didn't let you. They want you to just be able to think through to that point, which is frustrating, okay? So first tip, look for those backdoor options. If it says x plus y, it could just be x plus y, and you may not need to know x or y.
Okay, always look.
Okay? Read it carefully. Next one. We'll do 3 again. I'll give you just a little time extra. But.
Yeah, I think I got one similar to this one.
Did you?
I got one that was really.
I'm going to show you first how you can use Desmos to solve this, which is probably better for this test because honestly it's about the score, right? Annoyingly, it's not necessarily if you know all the math, it's can you test well. So, first thing, this is the next big tip. First one was sometimes you have to use the back door. Second one, anytime you see an equation, I want you thinking like y1 and y2. Right? These are 2 separate functions. You can think of it that way. And what does a solution mean? Where they cross. Okay? So if we're thinking of it this way, we can go to Desmos and enter both sides as a separate one. So 1/4 times absolute value of x minus, you know what it says, y equals 1/4. And then where do you find absolute value?
Bottom left.
Bottom left. Has anybody ever clicked on the functions one?
Oh.
There's a whole bunch of other stuff in here. Like there's all your trig stuff. You guys didn't learn inverse trig and, well yeah you did. I guess you did inverse sine, cosine, tangent, never mind. Okay? But just look at all these things in here.
Oh wow.
So just know that those are available to you in case you need more stuff. Okay? But for this, absolute value is easy to access. So x minus 4 I guess you have to close that. Okay, that's weird. Minus 30. Okay. So we have, hopefully you knew what an absolute value graph looked like, right? It's just a V. So we have that. Okay, for the other one, we're going to say y equals, and it was 2k. 2, and here's our letters, 2, it doesn't have to be k, but might as well put it in. Okay? And we need to add a slider for k. Usually it defaults to letting you do a slider.
If you don't have the y equals, then you'll get a.
Thank you. Okay, so if you just put 2K, so that's good to know. Thank you guys. If you just click it, add a slider for K. Now you can slide K to different values. Okay, and you can edit the values if you click on them. You can change where it goes in terms of. Okay, like let me click back. Right now it's defaulting -10 to 10. So let's zoom this out a little. So what are we looking for? Go back to the question. What's the value of K if this only has one solution? In other words, it can only what? Cross once, yeah.
Oh.
Okay, well I'm sliding K around and I haven't seen, why is it not graphing K?
Because we're in the hundreds.
Cause what? Yeah, but it's cause I don't have a Y equals K. You won't have to deal with the dumb pen. So that's nice.
That's fair. I'd
Oh,
love
there
that.
it goes.
Actually, I kind of would like to.
Y2K, you guys ran alive back then.
Y2.
Y equals.
So.
Okay, now we got it. So see how we can do this? Slider. Now it's moving the line. How many solutions does it have currently?
2.
Okay, and as far as down as -10, I still have 2 solutions. So you just go edit this. I don't know, put in -15 or something. Okay? And then keep sliding down and there. Okay? Now we have 1 solution. So do you see how you could do this on Desmos that way?
Yes.
Okay, you could also just play with different numbers. Once you can see the absolute value graph, you probably could have just looked down here and seen what number you need. Okay, now this is, go ahead.
So would the answer be -15 or would it be the coordinate?
Well, it's wanting the value of K, so it's just -15.
Okay.
Okay. Good to know.
You could have also just looked at where that point, the vertex is, and used that as well. Okay?
I'm guessing now.
We do have time to do this by hand, so now that I've shown you how to use Desmos, that probably would have taken you about a minute, right? By hand, remember how to solve absolute value? Actually, to save some time, let's work on this original. First, get rid of that fourth by multiplying everything by 4. And you guys just told me you don't remember this? This was just like 2 months
It was
ago.
like math rock, right?
Yeah.
It would be the absolute value by itself.
The one that's like this and then the positive, something that's
Yeah.
like negative. And then
Yes, it was math frog.
Uh,
Add
Let's see if
120.
you remember. I just forgot how to do it.
Okay, so to solve an absolute value equation, we do what Lexi's talking about. We do a positive and a negative version, right?
that does not look like math rock.
Yes, it does.
that's not mad flop. There we go.
That's math rock.
Okay. So we drop the absolute value and set it equal to the positive version. Drop the absolute value and set it equal to the negative version. Because remember, like if we said what's the absolute value of x, it gives 10. On a number line, it could come from -10 or +10. Both of those are 10 away from 0.
Okay, now I remember.
So that's why we're doing positive and negative. Anyway, continuing on, we just subtract the 4. So this one, 8k plus 116. Sorry, that's add the 4. Plus 124. Don't pack up. Over here, -8k. And then this becomes -120 plus 4, which is -116. Okay, so pausing there, the question asks for what value of k is there one solution? Which means these have to be what? Those have to be the same. So now we can set 8k plus 124 equal to -8k minus 116. Combine your like terms. And what is that, 240 I think?
Yeah.
Negative. Okay. You can do it that way. If you knew how, you could. But don't forget to do Desmos when you don't know how. Okay? So homework tonight is going to be some SAT problems. I'm going to post. Let me show you what it looks like. I'll post a test on there, and I'm going to put page numbers for you to do. The page numbers I'm referencing are the ones on the actual document down here. They'll be like 30s and 40s. Okay? And I think are you guys good on the continuous? Pass that tonight. We'll just do it in the warm-up. All right, so I'll post those. This is the problem that I was going to tell you. I don't want to go find it for time. W plus 7 equals 357. No joke. This is a problem on this test. You can look for it. And it gives you a multiple choice and asks for the value of W.
And if I mess that up, I'm actually.
No, actually,
that's-
it's
What if I like overthink it? The SAT